Hey everyone, Abel, Mathew. I'm on the backtrace team. And so I wanted to give you a small little talk about building a Go debugger. Not going to go too in depth, but I did want to give a small little snapshot of kind of the work that we did. But first, why the heck are we building a Go debugger? There's a lot of good interactive debuggers out there. Well, at Backtrace, we use debuggers in an unusual way. Maybe not unusual is the right word, but what we do is, at the time of error of an application, we use a debugger to take a snapshot of the application. So this snapshot includes all the Go routines, local non-automatic variables, and we do this so that developers and support people have a better idea of what was going on at the time of error. So this, in our opinion, is a little bit better than just the call stack. So the problem is that if we're going to do this for Go, we needed a Go debugger to be able to take these snapshots. But before I jump into how we actually did this, what's a symbolic debugger, or what's a debugger in general? So a symbolic debugger maps the state of registers in memory of the application to a backtrace with variables and type information. So here you see a small screenshot. I don't know if it's as blurry as it is on my screen right now, but you can see the Go routines. You can see the stack frames associated with the stack trace, and then local variables. So how does the symbolic debugger do this? The symbolic debugger uses debug information to do this mapping. So take the process image and be able to map to the symbols that we're familiar with. Dwarf is a popular format for this debug information. It's used by many languages, including Go, on some Unix-like systems. So Linux, you're going to see an ELF executable with dwarf information inside of it. So here's a small little program that I compiled. I did a little dump of information. You see that dwarf version 2 is being used, and you can actually see the attribute type language for dwarf language Go. The problem is that even with other languages, when you use various compilers, there's small variations in dwarf that's generated. So when you're building either a debugger or something that's leveraging this information, you have to accommodate those variations. It's not to say that there is a specification, but all of these variations come about because of the complexity or because of different issues with implementing the dwarf specification. So let's go ahead and dig into all of these issues within the next 2 or 3 minutes. I'm actually, sorry, just joking. I'm only going to go through one of these issues because it's very hard to be able to do this at any given point in time. So what I wanted to do was talk about multidimensional arrays. It's a pretty approachable topic. It's something we can easily go over. Actually, in the QA sessions right before this, they had a small comment about how Go actually views multidimensional arrays as slices, but these small variations present difficulties for debuggers. So here's a little excerpt from the dwarf standard. I do recommend reading the dwarf standard and all 200 pages of it, but if you don't have the time, here's the excerpt that says that multidimensional array is described by debugging information with children that specify the dimensions, where the leftmost dimension is it appears first in order. So this is what we expect when we see an attribute type of array. So here's a small C program, and if I compile this program and dump the dwarf information, I'll see the variable information, and then I'll see the array type, and then I'll see the 2 array dimensions. And then here's a small little visualization to see that the variable type now points to the subsequent entry within the dwarf information to be able to now interpret what this type is. So if we do this in Go, we see that there's a lot more dwarf information generated, and that might be because of a different interpretation of this type, as was mentioned during the QA session. So this mismatch actually presents a problem for our existing debugger. So this is the small variation that we had to account for. So visualizing this, what happened was we had to now interpret when we're dealing with a Go program and dealing with now array type, it's multidimensional, we had to now interpret it in this way. And so by doing this, now we can actually visualize and see multidimensional arrays in our debugger for a Go program. Let's see if I can now switch over to my terminal. And so many of you might be familiar with CockroachDB project. Definitely recommend looking at it if you haven't. So we've been doing some small tests with the CockroachDB project. And so what I wanted to show you guys was the Go debugger and, the Go debugger that we wrote and the small little snapshot that we took while CockroachDB was running. So I'm actually going to pull this up. And the screen resolution is a lot smaller than I expected. But so what we can see here is all of the Go routines that were extracted via our symbolic debugger. going to go down here and actually view this Go routine. And then here I can see the different frames. And then for each frame, if you notice, we're also viewing the variable information. So one of the cool things about building your own debugger is that you can use this to extract relevant information from your application at the time that it is running. So for something like CockroachDB, they might be very interested in the channels that we're currently executing, channels that were currently there, and the actual information or the metadata associated with those channels. So here, using our Symbolic debugger, what you're able to do is see the length, the capacity, different positions with the send and receive, and then actually, you can't see it here. Apologies for the resolution. But you can actually see the different Go routines that are subscribed. So that's the kind of things that you can do with by building the Symbolic debugger and then actually leveraging that to scan this information that's available. So obviously, there was a lot more issues that we went through, and there's going to be a follow-up post that we're going to post pretty soon here. And luckily, I just finished just in time, so good for me.